In this lecture, we are going to discuss about rolling contact bearings. So far in the fifth unit, we have already discussed sliding contact bearings. So from this lecture, we are going to discuss about rolling contacts bearing. So first of all, what is meant by rolling contact bearing? So the contact between two surfaces in sliding contact bearing, lubrication is used to split the inner race and outer race. In the case of rolling contact bearings, rollers or ballers are used to separate the inner race and outer race. Okay. So here very low amount of friction is produced because the balls and rollers are providing a smooth operation between inner race and outer race. A very low amount of friction is produced here. So you can see the animation. This is an example for a ball bearing. So let us see the construction first. So the inside hollow circle is called as inner race. Okay. Then the outer side is called as outer race. Then the balls are placed in between the two rays and a retainer is used to keep the balls in position. Okay. So the inner diameter is called as bore. The shaft will be inserted on the bore, and the maximum outside diameter is the diameter of the bearing. Okay. So the shaft will be inserted on the bore, and the shaft will rotate along with the inner race, and the outer race is placed with your stationary part, and in between the outer race and inner race the balls will be there, and the balls will rotate so that the friction will be reduced. So you can see an animation of rolling contact bearings. So this is the inner race and this is the outer race. So here you can see the balls, and the retainer is used to keep the ball in position. So in case of sliding contact bearing, there will be no rollers or balls, and only lubrication is used to separate the channel from the outer bearing. So here balls and rollers are used. So the advantages of rolling contact bearing. The first one, low starting and running friction except at very high speed. Because of using the balls in between inner race and outer race, the friction will be very low except at high speeds. So for high speed operations, we can go for sliding contact bearings. It can able to withstand high amount of shock loads. Then the accuracy of shaft alignment will be high, because in case of sliding contact bearing, at initial stage the channel will be at the bottom point, so the center of gravity will not match with the bearing center of gravity. Okay, but when it starts to rotate, because of the centrifugal force, the channel will come to its center in case of sliding contact bearing. So the alignment will be varying, but in case of rolling contact bearing, the inner race is a stationary one, and it will not move up and down, so that the shaft alignment will not be varying. Low cost of maintenance as no lubrication is required. So the maintenance cost is very minimum because we don't need to provide any lubrication. Then small overall dimensions, then reliability of service. So these are all the advantages of using rolling contact bearing. Then these are all the disadvantages. So the first one is more noisy at very high speeds, because the ball has to rotate, and when it touches with the outer race and inner race, it will produce some unwanted noises. Then low resistance to shock loading. Okay, so if the shock is produced, then it will damage the balls. Then more initial cost comparing with the sliding contact bearing. So design of bearing hosing is complicated. Okay, so around the bearing we have to provide a bearing hosing like this to keep the bearing in a stationary part. Okay, so the design of bearing hosing is a complicated one in case of rolling contact bearings. So next, the type of rolling contact bearings. So the rolling contact bearings can be splitted into two. One is ball bearing and the other one is roller bearing. In case of ball bearings, the balls are used in between the inner race and outer race. In case of roller bearings, instead of spherical ball, a cylindrical roller will be used to separate the inner race and outer race. So that is the difference between ball bearing and roller bearing. So first we'll focus on the ball bearing. The ball bearing is further splitted into two. One is radial ball bearing and the another one is thrust ball bearing. Okay, so in general the rolling contact bearing is splitted into two, that is ball bearing and roller bearing. Further this roller bearing is splitted into two. One is radial ball bearing and the another one is thrust ball bearing. Okay, in case of radial ball bearing, the bearing is designed to take only the radial loads. So that is the loads acting to the perpendicular to the axis of the shaft. So that is radial load. So this radial ball bearing can able to withstand only the radial loads. In case of thrust ball bearing, so the ball bearing is designed to take the thrust loads. So thrust load means axial load. The load will be acting parallel to the axis of the shaft. Okay. Also in some of the thrust ball bearings we can apply both thrust load as well as radial load. Okay, so this radial ball bearing and thrust ball bearing have small design changes in its constructions. So we'll see that in the next slide. So these are all the types of radial ball bearing. So the radial ball bearings are used to take up only the radial loads. So the first one is deep groove ball bearing. So it's the most common one. So the balls are used in between inner race and outer race, and a ball retainer is used to keep the balls in position. So that is deep groove ball bearing. In the case of fillet notch bearing, a small notch is produced on both inner race and outer race to keep the balls in position. You can see the image, a small notch is produced here. Okay. So that is fillet notch bearing. Then the next one is angular contact bearing. So in case of angular contact, the inner race and outer race will be in angular contact with the balls. You can see that. So if you draw the cross section, then it will be like this. So this is the top part and this is the bottom part. So your balls will be like this. So this can able to withstand radial loads as well as some amount of thrust load in only one direction. For example, if you see this image, if you apply a thrust load in this direction, then it can able to withstand the minimum thrust load. But if you apply the thrust load in opposite direction, then it cannot able to withstand the load because it will go in this direction. So the ball will not touch the inner race and outer race. Okay, so this angular contact bearing is designed in such a way that it can withstand axial loads as well as a minimum amount of thrust load. Radial load as well as minimum amount of thrust load. So the next one is double row angular contact bearing. Okay, so it's more or like your single row angular contact bearing. In single row angular contact bearing, a single row of balls are used. In case of double row angular contact bearing, two rows are used here. Okay, so the load carrying capacity of this double row angular contact bearing is moreover twice the single row, twice the load carrying capacity of the single row angular contact. Anyway, it will be slightly less than the double times of angular contact bearing, single row angular contact bearing. Then the next one is self-aligned bearing. In case of self-aligned bearing, so the retainers will keep retainers and the grooves provided in the inner race and as well as outer race will keep the balls in aligned. So it will keep the balls in aligned as by itself. So the standard designation. So the bearing standard is very important. So the bearings are mostly standardized based on its load carrying capacity as well as its bore diameter. So if a bearing number starts with 100, then it's extra light weight carrying, extra light load carrying bearing. So if it starts with 200, then it can able to withstand light loads. If it starts with 300, then we can apply medium loads. If it is 400, then it is for heavy load applications. Okay, so SKF is a manufacturer of bearing. So SKF has developed his own standard, and in this design we are going to follow the SKF standards only, and SKF is actually a manufacturer of bearing. So Svenska Kullankar Fabricant is the abbreviation for SKF, and this SKF standard is there in our data book, PSG data book, so we can directly take the standard bearings from our data book. Next one is the thrust bearing. So initially we have seen the radial bearing. So here it is thrust bearing. So in thrust bearings, we can apply both axial load as well as thrust loads. Okay, so the design is based on carrying thrust loads as well as the axial load. So this left side image is a single row thrust ball bearing, and this image, so it has two rows of balls. So it is called as double row thrust ball bearing. The next one is roller bearing. So in case of ball bearings, so balls are used in between the inner race and outer race. In case of roller bearings, the rollers will be used. So the first one is cylindrical roller bearing. So here a circular cylinder is used in between the inner race and outer race. You can see that. In case of spherical roller bearing, instead of circular roller, single row or multiple rows of spherical rollers will be used. In case of needle roller bearing, a cylindrical roller with high length will be used. Okay, so this is actually used for high thrust load carrying applications, the needle roller bearing. Then the tapered roller bearing. So here the roller will be kept in tapered position. Okay, so this is used for high thrust load carrying applications. Okay, so these are all the various types of ball bearings as well as roller bearings.